So let us look at what orchestration actually means. So if we talk about the definition of orchestration, so orchestration is the process of coordinating multiple components like the tools, models, memory, APIs to achieve a goal through structured execution. So if I talk about orchestration, it is the process of coordinating multiple components of an agentic AI system. So orchestration is the process of coordinating the tools, the models, the memory, the APIs, and why we are coordinating to achieve a goal through structured execution. So that is what orchestration is. So if I talk about orchestration, orchestration is basically the nervous system of the agentic AI system. We already know that the large language model is the brain. The large language model, LLM, is the brain of the agentic AI system. Tools are the hands. So orchestration is the nervous system which connects the brain with the tools and the memory. So that is what orchestration is. So orchestration is basically the process of coordinating multiple components of an agentic AI system like the tools, models, memory, APIs, and to achieve a goal through structured execution. So that is what orchestration is. So if we talk about the core idea of orchestration in agentic AI systems, so the core idea of orchestration is, so orchestration is decision layer plus the control flow plus the execution logic. So the idea is that the large language model, it will receive the input query, it will decode the intent, and based on the intent, based on the goal to be achieved, it will make a plan. So decision layer is all about making the plan. Decision layer is all about reasoning, planning. So in orchestration, we start with a plan, a reasoning, a planning. And then let us suppose if I want to accomplish a complex goal, then I will be breaking that into multiple steps. And that is where the control flow will come into the picture. Breaking a big task into small steps and then executing each of the steps. So now orchestration is very clear to us. When I talk about orchestration, I am talking about decision layer. I am talking about planning, reasoning. Like whatever the goal is to be achieved, I will make a plan. A large language model will make a plan for it. Then we will break the plan into small steps. So that is the control flow, breaking it into steps, multi-step task, and then execution, executing each of the tasks. So that is what orchestration is all about. So orchestration is decision layer plus control flow plus execution logic. So this is the core idea behind orchestration. So when I talk about orchestration, I'm talking about deciding what to do. I'm talking about control flow, how to do, like what structure I will be following, what steps I will be following, and the execution logic. So that is what the orchestration, the core idea of orchestration. Now let us look at the decision layer. So in orchestration, we start with the decision layer. So decision layer is like the planner. So in orchestration, the system evaluates the goal at every step. So in orchestration, the goal is evaluated at every step. So agentic AI system, it evaluates the goal at every step. Like at every step, it checks whether it is approaching towards the goal or it is drifting away from the goal. So the system, the agentic AI system, it evaluates the goal at every step. So two things are involved. One is the dynamic planning and the self correction. So in the decision layer, two things are being taken care of. One is the dynamic planning and another is the self correction. if I talk about dynamic planning, so so basically breaking a complex prompt into subtasks. That is what dynamic planning is. So the idea is that I want to achieve a big goal. So in order to achieve a goal, I have to break that goal into subtasks. So that is what dynamic planning means. So in orchestration, I will be doing dynamic planning and I will be doing the self correction. So in the decision layer of orchestration, we will be doing dynamic planning and self correction. So dynamic planning means breaking the complex prompt into subtasks, like the, so that is the decision layer of the orchestration. And in self correction, the idea is that if tool returns error, then the orchestration layer will decide whether to retry. So if the tool returns any error, then the self correction means the orchestration layer will decide whether to retry, execute the tool once again, or try different tool, or ask user for some clarification. So that is the idea. So now it's very clear that if I talk about the decision layer of the orchestration, it is also called as the orchestration layer, the planner. So here we do the dynamic planning wherein we break the complex prompt into the subtask, and the orchestration layer, it also takes care of the self correction wherein if tool returns any error, the orchestration layer, it decides what to do, whether to retry or to try a different tool, or whether to ask for clarification. Control flow, the control flow layer of orchestration. So control flow is the logical layer of orchestration. So this is how the system moves between states, because we know that we break a goal into subtasks. So how the system moves between states is what is decided by the control flow. So in control flow, basically there are three common shapes of orchestration. So the first is the linear. We also call it the chain. So the control flow can be linear, the chain. So in linear, it's basically a simple sequence. So the idea is that as linear means the output of tool A becomes the input of tool B, and like that. We can also have parallel execution. So the idea is running multiple tasks at once. So as we started, at the same time, we are running task 1 and task 2. For example, task 1 is searching Google and task 2 is searching Bing. So running task 1 and task 2 simultaneously and merging the results. So that is what is the parallel is. So we are discussing the control flow. Control flow can be linear, it can be parallel, and the control flow can also be cyclic, the loops. So in cyclic control flow, the agent keeps trying a task until a specific success criterion is met. So keep editing this code until it passes the unit test. This is an example. So cyclic, the idea is very clear. We start with a test, we start with a task, and we keep on retrying, executing that task until a success criterion is met. If the success criterion is met, we are done with the task. And if it is not met, we will retry. So that is the cyclic. So now the control flow is clear to us, because if we talk about orchestration, so control flow is the logical layer of the orchestration wherein the control flow, it decides how the system moves between the states. And we have three very common control flow. So if we talk about orchestration, it can be a linear orchestration wherein step by step, a simple sequence. It can be parallel. It means at a time, multiple tasks are running at once, and the, later we are merging the results of the task. And The orchestration can be cyclic, wherein the agent keeps trying a task until a specific success criterion is met. So now we will discuss the context and memory management, like how the orchestrator it deals with the context and memory management. So orchestration is not just about doing things, it's also about remembering. Orchestration is not just about doing things, it's also about remembering. So in orchestration, we also do the state management and information filtering. So if I talk about state management, the orchestrator it keeps track of what has already been tried. So the agent does not get stuck in a loop. So state management is all about keeping track of what has already been tried. So the agent does not get stuck in a loop. So that is what state management. So state management means whatever responses we are getting, we are storing it, or whatever steps we have taken, like the orchestrator, it will make a plan. It will decide a control flow, whether to go for a sequence or linear control flow or parallel execution or cyclic. So whatever steps or whatever the plan the orchestrator has made, or whatever the control flow logic it has decided, whatever responses it got, everything it will store. And that is what the state management is. So keeping track of what has already been tried. So that is state management. So the idea is that, like, we can understand it with a example, like let us suppose agent it attempts a task and it failed, then it will retry. Now this it will register it will store it somewhere, so that the agent, like we are storing it, that okay, agent tried a task and it failed and it retried, and once again it failed. So every time it is getting failed, that state we are storing it somewhere in the memory. So that is what state management is. So the idea is that this can be very helpful for the large language model in the long run, because large language model it is like storing the experiences. Large language model will get to know that okay, I tried this approach many times, but every time I got failed. So now I should try a different approach. So with state management, our system will become more experienced. It will learn from the real world experiences, because we know that large language model it already has got a knowledge. Large language model it already has got state of the art knowledge. It has knowledge of all the books, all the resources, but it is missing the experience of the real world, because we know that in our agentic AI system in the real world, a tool might behave in an uncertain way, and that real world experience we can make use of it if we store the experiences, if we store the state. Then our large language model will become very smart. It will learn in the real time that okay, this particular, like if I follow this approach, then I'm not getting the result, so I should try a different approach. So that is what state management is all about. If I talk about information filtering, so the orchestrator it decides which parts of a massive API response are actually important to pass on to the next step, preventing context window clutter. So the idea is that let us suppose we are getting massive API response, like the raw data. Now definitely we cannot fill all of the response into the context window, because the size of the context window is limited. So here the orchestrator will do the information filtering. So the orchestrator will do the information filtering, wherein it will decide what to include. So from the massive response, important context for the next step, the orchestrator will decide. So that we call as the clean data. So the orchestrator it decides which parts of a massive API response are actually important to pass on to the next step, preventing the context window clutter. So in this way, the orchestrator plays a role in memory management and context. So effective orchestration, it relies on maintaining context and filtering information to optimize agent performance and prevent redundant actions. So that is what context and memory management, like how the orchestrator does the context and memory management. Execution logic, the handshake. So if I talk about orchestration, orchestration also handles the execution logic. So execution logic is the technical glue. So basically the orchestration, if I talk about, it handles the authentication. Orchestration, it handles the authentication and the data formatting. So if I talk about authentication, passing the right API keys to the right tools. So this is been taken care by the orchestration layer. So orchestration layer, it also takes care of the execution logic, and in particular it takes care of the authentication, wherein the orchestration layer is responsible for passing the right API keys to the right tools, because we know that if we talk about third party tools, they might need some API keys, and in our Agentic AI system there might be a secret manager which is containing all the API keys, and the orchestration layer will just be responsible for passing the right key to the right tools. So securely delivering the right keys to the right tools is the responsibility of the orchestration layer. Orchestration layer is also responsible for data formatting. So converting the AI's natural language output into a JSON format. So let us suppose we know that the output of the large language model is like a natural response. Now the orchestration layer, what it will do, it will convert the natural language response into a JSON format like this, which the database can understand. So transforming human language into structured software input. So this is an example of a data formatting, and this is what is been taken care by the orchestration layer. So orchestration layer also handles the execution logic, wherein it takes care of the authentication and data formatting. Now let us discuss the importance of orchestration, like why orchestration is so important, why it matters right now, why orchestration matters right now. So in the world of agentic AI, we are living in the world of agentic AI, we are moving away from prompt engineering towards flow engineering. So we can see a transformation. We call it like the agentic AI shift. So we are shifting from prompt engineering to flow engineering. So we know that prompt engineering is all about finding the right words or giving the right words to the large language model. That is prompt engineering. And what is flow engineering? Flow engineering means building the right orchestration. So now we are not talking about giving the right prompts, but now we are talking about giving the right orchestration. And that is what the flow engineering is. And we are shifting from prompt engineering to flow engineering, and hence we can realize the importance of orchestration, because now the word of agentic AI is focusing on building the right orchestration, and this clearly is indicating the importance of orchestration. If we talk about prompt engineering is all about like finding the right words to be given to the large language model, and prompt engineering is like very like it's too simple, brittle, and it does not scale. But if we talk about flow engineering, which is the new paradigm, flow engineering is all about building the right orchestration. So building the right orchestration, so we will be building the orchestration layer. So orchestration is all about managing the agentic AI components or the capabilities like the tools, the memory, the models, and also different agents like specialized agent A, specialized agent B. So coordinating other agents, external tools, memory systems, human in the loop, input, output, large language models. So that is what is orchestration is. So the orchestration layer takes care of that coordination. Orchestration layer, it takes care of planning. It takes care of the execution, the control flow, monitoring, self correction. So that is what flow engineering is. And now we are heading towards the era of flow engineering. So the key takeaway is a mediocre model with great orchestration will always outperform a genius model with no coordination. So for agentic AI system, it's about system and not just model. It's not just about using genius model. Rather, it's more about great orchestration. So great orchestration is more important than a genius model because a genius model with no coordination is of no use. But a mediocre model with great orchestration can be of great use.